When we think we're thinking, what are we actually doing? Today, let's take a look at the nervous system. In a simple reflex circuit, stimulation of peripheral sensors initiates signals that travel centrally along the afferent axons of the sensory neurons. This information stimulates bio or brain motor neurons. The signals triggered in motor neurons then travel peripherally in afferent axons, giving rise to a behavioral response. So what exactly are these signals and how are they conducted? It's now known that the stream of consciousness and feeling is actually electric currented chemicals. In the axon of a neuron, neuronal electrical signals work. There's a constant voltage across the membrane of neurons when at rest owing to the asymmetric distribution of ions including sodium and potassium. When stimulated, sodium permeability of the membrane changes transiently and the sodium flux into the cell through channels, causing an intracellular potential change from the negative resting potential to the positive action potential. Then a rise in potassium conductance that activates in a delayed fashion drives potassium to flux out of the cell, decreases the potential back to negative. The potential changes lead to a local circuit of current flow from the action areas of the membrane to the adjacent resting membrane areas. Therefore, the sodium channels in these new areas open on a sudden voltage change, producing still more local circuits of current flow farther along the axon. Between two neurons, most electric signals turn into chemical signals to communicate the information through synapse. When the current spread along the axon and reaches the terminal, it will indirectly trigger the release of neurotransmitter. These substances are initially stored inside many vesicles docking on the presynaptic membrane. Ion channels on the postsynaptic cell are activated by the binding of neurotransmitters to postsynaptic receptors after release from the presynaptic terminal, and a flux of ions again triggers current along the second neuron. No matter what you think about the basis of neuronal signaling, for neuroscientists, it may be great romance to see our love, fear, and happiness as elegant currents and chemicals.